All right, so if we want to sketch the graph of the exponential function here, we have 1/2 times 5 to the x power. The first thing we need to do is we need to think of some values. And the values I'm always going to use are these, because exponential functions are going to be really big or really small really quickly. So what I need to do is I need to plug in -2 for this x. So for y, I'm going to have 1/2 times 5 to the -2 power. Well, 5 to the -2 power is 1/25. So I'm going to have 1/25 times 1/2. So that means -2 is going to have a value of just 1/50th. And so I'm going to plot that there. It's going to be super small. So this is 1/50. Okay, if I'm plugging in -1 next, then I'm going to have 1/2 times 5 to the -1, which is going to be 1/2 times 1/5, which is 1/10. So then I'm going to go to -1, -1/10, which is still almost 0. Then we're going to take 5 to the 0 power. That's easy, because anything to the 0 power is 1. So I'm going to have a value at 1/2. Then at 1, I'm going to have 1/2 times 5, which is going to be 5/2. So now we're moving up in the world a little bit. So we're at 0, 1/2. Now we're at 1, 5/2, which is 2.5. And then once we get to 2, we're going to have 1/2 times 5 squared, which is going to be 1/2 times 25, which is going to be 25/2, which is about 12.5. So I'm going to go 2 up to 12.5. And so what's going to happen to this exponential function? It's really small, and then it's going to get bigger really, really quickly. And that's true because this value that we're taking to the x power is greater than 1. Okay? Now, because I've written all over number 2, I'll show you number 3 instead. So number 3, we're going to do the same type of thing. We're going to pick our values, and hopefully I do a better job. So I have x and y, -2, -1, 0, 1, and 2. Now this is going to look a little different because we're taking 1/2 to the x power. So I'm going to have 5 times 1/2 to the -2. Okay. Well, if I'm taking 5 times 1/2 to the -2 power, what that's really going to be is 5 times 2/1 squared. So because that exponent was negative, I flipped my fraction. So this is really 5 times 4, which is 20. So I'm at -2, +20. Then at -1, I'm going to have 5 times 1/2 to the -1, which is going to flip, so I'm going to have 5 times 2/1. So there's 10, so I'm at -1, +10. Then we're going to plug in for an exponent of 0, which is just going to make this 1, so I'm going to have 5 times 1, which is 5. So I'm at 0, 5. Now if we plug in 1, we're going to have 5 times 1/2 to the first power, which is just 5 times 1/2. So I have 5/2. So I'm going to have 1, 5/2, which is 2.5. And then the last one is going to be 5 times 1/2 squared, which is 5 times 1/4, which is 5/4, which is just barely more than 1. So in this function, I'm kind of doing the opposite of that, and that's because I'm taking a fraction to an exponent. Whenever I'm taking a fraction to an exponent, I'm going to have a decay function, and here I'm taking an integer, which is going to be growth. All right, there we go.